In this lecture, we're going to start covering classical or Pavlovian conditioning. Now, last time we talked about habituation, and that was event-alone learning, where we were learning about a single stimulus that we were presented with repeatedly, and then behavior was changing because of that repeated occurrence. So now, with event-event learning, now we're going to look at the relationship between two stimuli that are presented. So, two separate events. And again, we're going to see that we have lots of different possible names for this. Classical conditioning is one, Pavlovian conditioning is another. And the reason why it's sometimes called Pavlovian conditioning is because it was established by Ivan Pavlov. Some of you may have already heard of Pavlov, but just in case, here's a brief overview of the history here. So Pavlov was a pretty well-known Russian researcher. He was working in the early 1900s, and despite the fact that right now he is well known for his understanding and development of things to do with learning, at the time his research was actually based on understanding digestion. So his lab was set up where he had what was called a cannula, so basically a rubber tube that ran from the mouth of a dog. I think he also had other animals as well, but you mostly know him for his work with dogs. And he was collecting saliva to look at sort of what enzymes and what processes were going on that were involved in digestion. And while he was doing this, he noticed that something strange was going on. So every morning, his graduate students would come into the lab, they would open the door, the door had a bell on it. So they opened the door, it rang a bell, and then they would go and they would start their day, they would feed the dogs, they would start collecting saliva and all of that. But they noticed that the dogs started producing saliva even before they were given food. Now, being given food is a pretty quick way to have saliva developed. So even if you think about food, you're usually going to have your mouth water. So having food placed in front of you is a very fast way to get saliva flowing. But the students were finding that the dogs were producing saliva even before there was food out. And so they found that the dogs were actually associating the sound of the grad students coming into the lab, that ringing of the bell when they walked through the door, was telling the dogs that food was coming soon, and they started salivating in advance. And so this process, this association of that sound that meant that they would eventually be getting food, is what prompted what they now call classical or Pavlovian conditioning. And so if we want a technical name, we can say that our classical conditioning is a form of learning in which a neutral stimulus comes to signal the occurrence of a second stimulus. So some stimulus that was previously neutral will eventually elicit a response because it signals the occurrence of another stimulus. So here, the sound of the bell was something that was previously neutral. A bell doesn't necessarily mean anything to a dog, but it came to signal that the dogs would be getting food, and so they reacted to the bell the same way that they would react to getting food. And the terminology is going to make a little bit more sense as we walk through the rest of this section in the chapter. And before we get into sort of classical conditioning specific terminology, I put together a couple of terms that I find are fairly useful for learning in general. So some of these might have slipped into my vocabulary beforehand, but I wanted to put them sort of in one place where you could see an explicit definition, just in case you are a little bit confused about the meaning of any of these. So I might have mentioned that a stimulus could come to elicit a response. And this just means that a stimulus brings about a particular response, or it causes a particular response. We researchers like to avoid the term causes because of sort of the reasons we mentioned back in chapter 2 for methods. So elicits is a better term because we are not intentionally trying to say causes, we're just saying that there's a relationship going on. So it brings about the occurrence of a particular behavior. So ringing that bell came to elicit the dog's salivation response. We're also talking about stimuli or if we want the singular, a stimulus. And this is basically anything in the environment that we can detect, that we can measure, and that we can use to evoke a particular response or behavior. So this definition is a little bit more strict than, say, the definition we talked about in our sensation and perception chapter, and that's because we're specifically looking at stimuli that are related to learning. So we need them to be able to evoke a particular response or behavior. But our stimulus could be a smell or a sound or a sight or basically anything that we can detect in our environment. Another useful term is association. So if we talk about creating an association between two stimuli, we are talking about creating a relationship where we learn something about how those two are related to one another. And then we might also talk about acquisition. And this is the time while we're acquiring or picking up on a particular association. So acquisition is the learning period where we learn about the relationship between two or potentially more stimuli. So when we talk about acquisition, that's the early stages of conditioning while we're still learning. Okay, so those are useful learning terms, but now we're going to get into our classical conditioning specific terms. And I want to start, before I get into the specifics of the terms here, I want to point out that there's sort of a little bit of an unfortunate thing going on with the terminology for this specific type of science. And that's oh, that's unfortunate, that's a black color. I would like something a little bit more visible. There we go, pink. So you're going to notice that we're talking about unconditional, and then on the next couple of slides, we'll be looking at conditional stimuli. I might accidentally slip up and talk about conditioned and unconditioned stimuli instead of unconditional. And that's because there was an unfortunate translation error. So as I mentioned, Pavlov was working in Russia. And so when the literature was translated over to English, they had originally translated as unconditioned or an unconditioned stimulus or an unconditioned response. But the more grammatically correct form is to say that it's an unconditional stimulus or an unconditional response. And so most texts are starting to update to the sort of grammatically correct way of saying it. The unfortunate part is that I learned it with the old version, so I will occasionally say unconditioned and unconditional, or instead of unconditional, just because of experience. So I wanted to make it very clear that if I say it differently, it's not that I'm referring to a different concept, it's just that I was taught the same concept with a different name. And as we've seen multiple times in this course, there's a lot of similar ideas or similar concepts that have different names. These ones are just unfortunately very close together. So that's just my quick disclaimer at the beginning. So I'm going to try and say unconditional, but I might slip up just from force of habit because I've been studying learning for quite a few years, so it's pretty hard ingrained in my brain. With that random rant and rambling out of the way, let's actually talk about these terms themselves. So I've been talking about conditioned and unconditioned, or unconditional and conditional, but what do we mean here? And so we're going to kind of break these down. So we're going to see some very similar terms, and for classical conditioning, the terminology is very important. So we can have an unconditional stimulus and an unconditional response. So what we mean by unconditional, it means that it's something that happens unconditionally. It doesn't require learning. It's going to happen naturally. And then if we're talking about a stimulus, that's going to be a particular event that's going to lead to a particular response. And then the response is the behavior that's produced because of that particular stimulus. So our unconditional stimulus, which we'll call a US, is a biologically significant stimulus that already has a response associated with it. So if we think of our example of Pavlov and the dogs salivating when they have food, food would be an unconditional stimulus, because whenever you give anyone food, they're going to start salivating. That's a natural response to being given food. So food would be an unconditional stimulus, And then that salivation, that response that occurs naturally when you're exposed to that stimulus, would be an unconditional response. Another small notation note here is sometimes you'll see people call these a UCS instead of just a US because they focus on sort of the conditional part. I find that if you're going to use an acronym, you should only use the first letter of each word, which is what I stick with US, but you will occasionally see textbooks that use UCS and also UCR. But again, it means the exact same thing. Just the joys of being in a very diverse field that's made a lot of changes over time. So I will try and consistently use US and UR, but don't be startled if you see others when you're looking into this topic. Okay, so we've set up our unconditional stimulus and our unconditional response. They are unconditional, they occur without learning, so they occur naturally on their own without us getting involved. What next? Well, next we can have our neutral stimulus. And so we mentioned at the beginning that a bell doesn't necessarily mean anything to a dog. We could call it a neutral stimulus because it's a stimulus that does not naturally elicit any kind of response. So a tone or a bell or a chime, those would all be examples of a neutral stimulus. These all happen to be auditory cues, which they don't have to be. You could have a particular color or a particular shape or sort of visual things or even tactile things or even smells. Again, it could be any kind of stimulus that doesn't have a naturally associated response. But the easiest ones that we typically see are auditory cues. So we'll mostly focus in on bells and tones, at least for today. Okay, so that bell starts as a neutral stimulus because it doesn't cause any kind of behavior, but eventually we do start learning something about that bell. That's the whole point. When we go through the acquisition phase, we acquire an association between this neutral stimulus and the stuff that we already had, those the unconditional stimulus, and then the response associated with it. So this is where we change things up a little bit. So our neutral stimulus, that bell, will eventually become a conditional stimulus. So this is a previously neutral stimulus that will eventually come to elicit a conditioned response or a conditional response. So this is saying that if we pair that bell with food often enough, then the dogs will start associating that previously neutral bell with the delivery of food. And so eventually the dogs will salivate when they hear the bell sound. And so once they've learned something about that bell, then we can call it a conditional stimulus because it's leading to a response, a learned response. So it is a stimulus that they have learned something about. We have conditioned this particular stimulus. And then the response that they produce would be called a conditional response. So it's a learned response that's produced to some kind of environmental stimulus, which was our previously neutral stimulus that we now call a conditional stimulus. Now, I am aware that this is a lot of words and a lot of strange terms to pick up all at once, so if it hasn't sunk in quite yet, that is perfectly fine. What I am going to do is walk through all of these terms again using our Pavlovian dog and bell with food setup. And we're going to talk about these terms just a little bit more detail to help you understand sort of how they're used and what's going on at each of these stages. So let's do this with an image. So we're going to start before conditioning. So this is before we learn anything. So we will have our unconditional stimulus. So this is a stimulus that we don't have to learn anything about. It's going to produce that unconditional response no matter what because they don't have to learn about it. So if you give a dog food, they're going to salivate. So the food is an unconditional stimulus, and that salivation would be an unconditional response. That's not too bad, okay? Before conditioning, that bell sound is also going to be a neutral stimulus. So if you ring a bell at a dog, they're not going to do anything. They're not going to salivate. They don't know anything about the bell. So there's no conditional response here. There's nothing going on. And so because there's no conditional response, we still call this a neutral stimulus. During conditioning, or if we look at this as our acquisition phase, while we're acquiring or learning this association, we would ring the bell and give the dog food at the same time. So we're pairing them together, hoping that the dog learns something about the association or the link between the bell and the food. And so during this process, during acquisition or the conditioning process, we would have this pairing and it would lead to an unconditional response. So the dog is going to be salivating and it's probably being driven mostly by the food presentation. So we're calling this still an unconditional response because it's still being driven by our unconditional stimulus. The dogs are salivating because of the food. But while they're salivating because of the food, they're also learning something about the bell. So then after conditioning, or after we've gotten out of that acquisition phase, we can test, we can do a trial where we only present the dog with the bell. And so if we ring the bell and the dog starts salivating, we know that the dog is salivating in response to the bell because there's no food present in this test trial. So we would say that this is a conditional response. They are salivating because they learned something about the bell. And because we have a conditional response being produced, we know that the bell is now no longer a neutral stimulus. They've learned something about the bell, so we would call it a conditional stimulus. Just to make sure that this is sunk in, we're going to do this one more time, but with a slightly different visual here. And we're going to be focusing on the relationships between these different aspects here. So we're back at the beginning here, before conditioning. So we have a neutral stimulus. We don't know anything about the stimulus. It doesn't cause any kind of response. It's just a neutral stimulus by itself. Then over here, we have our unconditional stimulus. That would be our food. And then the unconditional stimulus, even before conditioning, is related to directly this unconditional response. So when the dog gets that food, they're going to salivate already because of this association. So that's something they already do. They don't need to learn it. It already exists. Awesome. Okay, so now during conditioning or during our acquisition phase, now we're going to present our neutral stimulus and our unconditional stimulus at the same time. So we'll ring the bell, we'll give the dog food, and they're going to be salivating. So we're forming this link here. This smaller green line is a new association forming between our neutral stimulus and our unconditional stimulus. So we're learning that the bell is associated with food, and because we're getting food, the dogs are going to be salivating. So we're forming this sort of indirect relationship where, okay, so the bell means food, and when we get food, we salivate. So that's during that conditioning process or during acquisition, we're developing this relationship, this association. And then after conditioning, our neutral stimulus is no longer neutral. Now it's a conditional stimulus. We've learned something about it. We've learned that there's an association between the conditional stimulus and the unconditional stimulus. And now, our being presented with that unconditional stimulus will still lead to our unconditioned response or unconditional response. So if you give a dog a plate of food, they're still going to salivate. But because they've learned that our conditional stimulus, our bell, is associated with food, when we ring the bell on its own, we're going to see a conditional response. So because the dogs are now salivating, because of us ringing the bell, we're going to call it a conditional response. So salivation could be a conditional or an unconditional response, depending on what's causing it. So if they're salivating because of the bell, then it's a conditional response. But if they're salivating because of the food, then it's going to be an unconditional response. So when we're telling the difference between these two types of responses, we want to pay attention to what's leading to the production of that particular response. So if it's being caused by our conditional stimulus, then it's a conditional response. But if it's occurring because of our unconditional stimulus being presented, then it's an unconditional response. So that's just a good one to practice. Next, we're going to talk just a little bit more about our unconditional stimulus. And so, right now, we've only been talking about what are called appetitive stimuli. And so, an appetitive stimulus would be something that the animal finds pleasant. So, food is a great example of an appetitive stimulus. But we could also use things like being able to play, or getting attention, or smelling something they enjoy. So as long as it's something the animal finds pleasant, we could call it appetitive. So then we can have appetitive classical conditioning. We can also have aversive classical conditioning. And if we're looking at aversive conditioning, then we're saying that our stimulus is aversive. It's something that the animal finds unpleasant. So this might be a loud sound, a lack of light, or especially in some of the older conditioning literature, they would use a lot of sort of mild shocks as an aversive stimulus. We don't see as much of that anymore as we've sort of moved forward in our understanding of ethics and equal treatment and not doing things to animals that don't need to be done. But a lot of the older literature will talk about things like mild shock or things like that. Okay, so those are the two types of our unconditional stimuli. But what makes a good unconditional stimulus? Well, to be effective, we really want an unconditional stimulus that will evoke a strong bodily response. So something that's going to produce a fairly strong unconditional response. This is one of the reasons why the early research used to use things like shocks, because it would produce a fairly strong response, a startle response. So we'll often see things like you might have direct brain stimulation. You might have exposure to a loud noise, which would create a startle response. There's even some really neat research looking at how exposure to different kinds of drugs can be conditioned, which is very cool. But the idea here is that the more intense our unconditional stimulus, the easier it will be to produce a conditional response. So the more intense our initial stimulus is, the easier it is for that association to be learned. But of course, there's a caveat here that only applies to a limit. At some point, if your unconditional stimulus is too intense, it can actually end up inhibiting the learning process. So more intense up to a point is desirable. Our next couple of slides, we're going to look at ways that we can pair together our conditional stimulus and our unconditional stimulus. So far, I've talked about, we just show them together. So we ring the bell and we give the dogs food. But we haven't specified the timing or the order of that presentation. And so now we're going to do that. We're going to talk about different times of CS-US pairings. And different types of pairings are going to be more or less effective at us acquiring an association. So we're going to start with the two probably most straightforward ones, short delayed and long delayed conditioning. So for short delayed conditioning, we're going to have the conditional stimulus turn on, and it's going to stay on. And shortly after it has started, the unconditional stimulus will start. So our unconditional stimulus starts just after that conditional stimulus has started. And if we hop to this second slide here, we can see that we have our conditional stimulus here is presented, and then shortly afterward, we have our unconditional stimulus presented. And so the idea here is that you would see lightning, and a flash of light doesn't necessarily mean anything to you, so it starts as a neutral stimulus. But eventually, if you see lightning and then shortly thereafter hear thunder, and thunder is a loud sound that's scary, it makes you jump, then eventually seeing lightning might also make you jump because you know that thunder is coming. So as long as there's a fairly short delay between the appearance of lightning and the appearance of thunder, then we're going to call this a short delayed conditioning. And so you'll note here that our conditional stimulus is still on, or it's still going, when our unconditional stimulus begins. So there's an overlap in the two there. Our long delayed conditioning is the exact same thing, but with a longer delay, as the name might make you think. So if it's only a couple of seconds, we're calling it a short delayed conditioning. And if it's longer than a couple of seconds, so 30 seconds or more, then we would call it long delayed conditioning. And for the purposes of testing and things like that, I would talk about either sort of like under 10 seconds being short, and then maybe minutes or more would be long delayed, just so that there's no sort of uncertainty as to which category it falls under. In practice, you'd probably end up specifying if you were calling it long or short delayed conditioning in your paper if you were doing research, just to tell people, maybe using an operational definition of what you were calling things and how you were setting it up. But for us, a few seconds is short, and sort of around about a minute or more would be long. Our next types of pairings are trace conditioning. So trace conditioning is very similar to what we just saw with our delayed conditioning, but here our conditional stimulus will begin and end before our unconditional stimulus is presented. So again, if we hop to our next slide, we can see that we would have our conditional stimulus presented, and then there's a delay. So there's a period where that conditional stimulus is no longer being seen or experienced, and then we will have our unconditional stimulus. So they're using the example here of you eat something bad and then you get sick later on, and then you would eventually associate food that tastes bad with getting sick. But trace conditioning can be sort of any kind of gap in timing. So even if our conditional stimulus is off for a few seconds, and then we have our unconditional stimulus, that would be trace conditioning because there is no overlap. So our short and long delayed conditioning, they have that overlap of the two types of stimuli, and then our trace conditioning does not have an overlap, just to help you tell those ones apart. Then if we wanted to look at simultaneous conditioning, that's a nice easy one, where our conditional stimulus and unconditional stimulus, they begin and end together. So we're going to have them both start and end at the same time. They're presented simultaneously. So we have an overlap here. And it's kind of weird. They've shown a gap, but they've stated that that gap is 0 seconds. I don't know if it would have been clearer to have them just directly on top of each other, but they're saying that there's a gap of no seconds, so they're simultaneous. Just weird visuals there. And then the last one is backward conditioning, and backward conditioning is probably one of the easiest to remember. I guess simultaneous is pretty easy to remember too, but this is, for backward conditioning, it's basically the opposite of our other ones. This is when our unconditional stimulus occurs before the conditional stimulus. So instead of ringing the bell and then giving the dog food, you would give the dog food and then ring the bell. And so just from that description, you might think that this one might not be the most effective form of pairing, and you would absolutely be right. Backward conditioning is the least effective type of conditioning, but it is still possible if you make enough pairings. And then for a visual of that, you would have it sort of backwards. So your unconditional stimulus is presented first, and then your conditional stimulus. And it's kind of hard to associate backward in time, so this one isn't always that effective. Okay, so if we're trying to learn an association, how can we actually make that more effective? How do we enhance that acquisition process? The best way to do this is to have multiple conditional stimulus, unconditional stimulus pairings. So, like our example with the dog, ringing the bell and giving them food, if you only do that once, they're not necessarily going to learn anything about the relationship between the bell and food. But if you ring the bell and give them food 100 times, they're definitely going to be more likely to learn that association. So more pairings will usually give you a stronger association. However, there is a sort of special case where we can have one trial learning. So especially with very intense, aversive, unconditional stimuli, we can have a situation where only a single exposure can lead to you learning that association. And the best example of that is actually learned taste aversions. And so I always use the example of when I was a child, I used to love apple juice, but I lived in southern Ontario where it got very hot in the summer. And so one day I left a bottle of apple juice in the car while we were visiting relatives, and I came back, 8 hours later, thinking that I was going to drink the apple juice that I had left roasting in the sun at 30 plus degrees for the entire day. And so I drank the whole thing and I immediately threw it up. And since then, I do not enjoy apple juice. Even thinking about apple juice makes me feel nauseous. And so what I have is a case of conditioned taste aversion. And so if we wanted to look at sort of our conditional versus unconditional stimulus and response here, we could say that, okay, so starting with our unconditional, the stuff we didn't have to learn about, we might have sort of an illness-causing bacteria or whatever quality it was in the apple juice that made me sick. The unconditional response is being sick. I threw up because of something to do with that apple juice. Then I've learned something about that association. So our conditional stimulus, the thing that I'm learning about, is the taste of apple juice. So I didn't have any negative associations with apple juice before. It was just a drink that I would have. But now that I've had apple juice and gotten sick, or had apple juice, been exposed to something that would make me sick, and then gotten sick, I associate that apple juice with that whole process. And so now when I think of or even taste apple juice, it makes me feel sick already. I have a learned or conditional response to that particular flavor. So I have learned about that stimulus. We can call it a conditional stimulus now because of that single exposure when I was a child. So taste aversion is one of those really intense situations. We also have sort of a biological predisposition to learn things like taste aversions. And that's because evolutionarily it makes sense that if something made you sick, you should stop eating it because it's probably bad for you. So this is one of those things where we probably have that biological predisposition to learn about things that make us sick and to not eat them anymore. But back to other things that we can do to enhance acquisition, we can use that short delayed pairing, the first of our pairing types. So if we ring the bell and then give the food right away, then the dogs are going to learn that the bell and the food are very closely linked. So by having them closely located together in time, then it's a lot easier to form an association between those two stimuli. And if you can't have short delayed pairing, if you could have sort of a short, if you had trace pairing, but with a very short interval between the two stimuli, that would be your second best option. But these are sort of our ideal situations to enhance acquisition. And on the topic of talking about us being sort of biologically predisposed to acquiring taste aversions, I also wanted to take a brief moment to talk about the concept of preparedness. And this is going to be, again, sort of a biological predisposition to form certain types of associations. And so in the text, they talk about an experiment that was done, I believe in the 1980s, where they had rats who were given water. And so at the beginning, they had sort of tubes of water, and the water was flavored with something sweet. So it was tasty, but it was also, it had light and it made sounds. There was static and light near the water as well. So they had bright, noisy, and tasty water all at once in one tube. One group of the rats was then presented with a shock after drinking from it. Another group was given X-ray exposure after drinking from it. And we wanted to see what they learned based on what kind of stimulus they were exposed to. And so let's just look at the group that was shocked first. So the group that was shocked after drinking from that tasty, bright, and noisy water at the beginning, they were exposed to sort of a physical stimulus, and a shock could simulate injury. So that's sort of like a physical, tactile sensation for them. And we look if they were given the choice of drinking from water that was either bright and noisy, meaning that there was light and sound nearby, or they could choose to drink from water that was just sweet, but with no light and sound. Those rats would choose to lick or to drink the sweet water, and they ended up trying to avoid the water that was bright and noisy. So this tells us that they were associating the pain of that shock with sort of these physical traits of sort of being bright and noisy. So light and sound were associated with something that was physical in response. So that was what they started avoiding because of what they learned at the beginning. And then it gets really cool because the group that was exposed to X-ray, so the side effects of exposure to radiation is nausea. So these rats were sick. So they had basically the same as being exposed to a food that would make them sick. And so in this group, because their unconditional response was sickness, they associated the tasty water. So they thought that it was the sweetness that made them sick. And they didn't avoid the water that was bright and noisy. So when given the chance to drink from water that had light and sound nearby, they were fine with that. But they avoided water that tasted differently. So they associated something that made them sick with the taste, and they associated something that hurt them with sort of the physical appearance and the sound of it. So this shows us preparedness, where we tend to think that things that make us sick are related to eating and tastes and things like that, which kind of makes sense. So if the rat had eaten something that was bad for them, then it would make them sick. So the flavor of the water was more closely related to that sickness, so they were prepared to learn that association. But when they were experiencing physical pain, they didn't associate the taste of the water with being in pain. Instead, they would associate the appearance and the sound of the water. And that kind of makes sense. If you think of other times they'd experience pain, maybe they encounter a predator. They might see and hear the predator before they are in pain from being caught by a predator. So we show preparedness to link sort of that physical, sort of visual aspect and auditory aspect with painful stimuli. So we are biologically set up to acquire different kinds of association a little bit more easily, and we can call that concept preparedness. So all of this has been about learning or acquiring different associations. So we're learning about two different stimuli. We're acquiring different behaviors. But what happens when we want that response to decrease? What happens when we want to stop that learning process? Well, now we're going to talk about, okay, we're going to decrease our conditional response. We want the dogs to stop salivating when they hear a bell. And so our steps from the text say that in this excitatory conditioning, and by excitatory conditioning, we just mean conditioning where it will produce a response, that conditional stimulus, the bell, will elicit a conditional response. So we had set up an excitatory conditioning setup with our dogs, with the bell and food, and so ringing the bell makes the dog salivate. It's our conditional stimulus and conditional response. In the process of extinction, specifically looking at extinction as it relates to classical conditioning or Pavlovian conditioning, we want to sort of extinguish or get rid of that association. So we would have the unconditional stimulus, the presentation of food, no longer occurs. So we would ring the bell, but we wouldn't give the dog food anymore. And so as the dog hears the bell but doesn't get food, they're going to sort of weaken that association. our conditional stimulus, the bell, will eventually no longer be associated with our unconditional stimulus because they're not encountering them both together again. And over time, that conditional stimulus will no longer elicit the conditional response. So if you ring the bell often enough without giving the dog food, eventually when you ring the bell, they won't salivate to the bell anymore. So that process would be called extinction. And so we could say extinction is a process in which our conditional stimulus is presented in the absence of our unconditional stimulus. And it causes our conditional response to weaken and eventually disappear. It's just sort of the plain English version of all the stuff on the other page. And so if we wanted to look at a visual representation of this, we have a graph where we have our sort of strength of conditional response on our y-axis. So at the bottom would be very little responding, and at the top is a lot of responding. So if we were still looking at our dogs and salivation, at the bottom would be they're not salivating at all, and at the top would be they're producing a lot of saliva. And then our x-axis is just time. So if we look at our acquisition phase, this is when we're learning that association at the beginning. So we would pair our conditional stimulus and our unconditional stimulus, and sort of eventually we will have more and more of a conditional response. So as we acquire this association, we'll start seeing more of a conditional response to our conditional stimulus. We get more salivation when we ring the bell. Okay. Then we start presenting our conditional stimulus alone. There's no more food presentation here. We're not presenting our unconditional stimulus. This is extinction. And what we should end up seeing is a decrease in the amount of that conditional response that we see. So the dog starts salivating a lot because they had learned an association, but over time that they go through extinction and they no longer salivate when they hear the bell. Next, we have a weird occurrence that can happen, and this is something called spontaneous recovery. And this is when a seemingly extinct conditional response reappears if our conditional stimulus is presented again following a delay after extinction. And this is going to produce usually a weaker conditional response. And so what this means, and I'll do this with the visual here, what this means is if we go through extinction and the dog stops salivating when we ring the bell, if we take a break, maybe we take a day off, or maybe we come back the next morning and we ring the bell with the dog there, they're going to salivate a little bit. Not as much as when they had acquired that association, but they're still going to salivate a little bit. And this new occurrence of our conditional response would be called spontaneous recovery. And then if we do extinction again and present our conditional stimulus alone, we can have a drop-off in the responding here again. So we can go through extinction again. And then the idea here is if we had another pause, so we took another day off and we came back the next day, we could then see spontaneous recovery again, but it would probably be even lesser. And so you could go through multiple rounds of extinction and those pauses in order to get rid of or sort of unlearn this situation. It's a little bit more complicated than that, and if you ever take sort of a higher level learning course, you'll find that extinction isn't so much unlearning, but learning a new association or learning a new lack of association, I guess. But that is a little bit beyond what we need for this course. I do want to mention one other sort of special case that we can talk about, and these are safety signals. And so this is the idea that you can have a stimulus that actually tells you that a unconditional stimulus is not going to occur. So this would be, we can call them either a safety signal or a conditioned inhibitor. But it's basically something that tells us that a particular stimulus is not going to come. And I'm going to explain this through with an example on the next slide. So we're going to start with our conditioned exciter. So excitation just means that it's producing a particular response. So conditioned means we've learned about it, and exciter means that it's producing a response. So a conditioned exciter would be a conditional stimulus, a CS, that ends up producing a conditional response. So if we go to our next slide here, we have a blue square. So if we present this blue square and pair that blue square with a puff of air to your face, you're going to have a startle response. You're going to blink and usually jump just a little bit. So if that blue square is always paired with a puff of air, then the blue square will eventually become a conditioned exciter. It will become a conditional stimulus that elicits a conditional response, that startle response. So eventually the blue square on its own is enough to make us jump even if there is no air present. So we've learned that this blue square means air to our face, so we will jump. If we then get a conditioned inhibitor or a safety signal, this is a conditional stimulus that lets us know that an unconditional stimulus is not coming. So it tells us that we're safe from that unconditional stimulus. So back to this example here, if we have a purple triangle, and that purple triangle tells us that even though both of these had sort of this generic gray square in the background, gray triangle, oh my goodness, star. Apparently it's one of those days. This shape is a star. So pairing the square with the star means air, but pairing a triangle with the star means no air. And so then we would learn that seeing this triangle tells us that we're safe. And so we would learn not to flinch when we see the triangle because the triangle tells us we're safe. So that gives us extra information where we learn that we don't have to respond.